Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions. Your questions in the question and answer window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Ramsey Shanbaki from Repen.
Thanks, Leah. Today I'm here to talk about the inline concentration measurement via the FlowVPX system and how it can fit into your process and present some data on it and answer your questions. So today I'm going to talk about first why we need process analytics, how slope spectroscopy works and the method of use of the FlowVPX system, and then a sampling of data that we've collected with our customers on various process steps with the FlowVPX and how it can help you in your process. But first, I'd like to just go through and quickly show the suite of products that's offered by Repen. Today we're talking about the FlowVPX system that you can see on the top right-hand corner, alongside our flagship benchtop spectrophotometer, the SoloVPE system. But Repen has a wide variety of products they offer for both upstream and downstream. The ATF cell retention system that intensifies the process, various TFF systems, flat sheet cassettes and hollow fibers, the Artisan single-use chromatography and TFF systems, and of course our Opus pre-packed columns. So we have a suite of products, and we're happy to answer any questions about all of those. So here is displayed a typical bioprocess, starting from the left-hand side in the cell culture upstream side, and moving to the right-hand side of the screen, showing the purification and filling. The FlowVPX is typically used in the downstream part of the process, so anywhere from harvest all the way to filling. The examples I'll show today are focused on the capture chromatography step, filtration or UFDF, and the final formulation of your MAB product. So why do we need process analytics? Process analytics exist in the process today. What we're talking about is improving them and putting them in line while the process is operating. So the situation right now is that you have raw material inputs and a very constrained process. That process then outputs a variable material that you then have to look at the CQAs on and understand and fit into error bars the critical quality attributes of the product. The future that we're proposing, and other companies such as Repen doing process analytics are trying to do the same, is to put an instrument into the process, and the future state would be that the process is somewhat adaptive. So you can use the information like the concentration to, for example, load columns or start and stop a process. This allows the process to be a bit more adaptive, and then at the end of the day, you have a tighter error bar on your process and predictable quality attributes. So the question is, well, how do you do this? Typically, it starts in a process development lab. So the process development folks would get an instrument, start using it in various process steps, and gain that understanding based on the inline instrument. Next, you may want to put it into a later stage in the process to do IPC testing or in-process control testing and allow yourself to remove sampling steps for manufacturing. This could be done in a clinical suite or a later stage process development pilot suite. And then finally, you would want to connect that instrument to the process, allowing process control and giving you that highly reproducible result. So that kind of three-step process, it doesn't happen overnight. It may take a couple years and a number of people, and there's a lot more to it, but that's generally how we've seen our customers implement this product. So I'll briefly go over how the slope spectroscopy technique works. And this is true for both our solo VPE and our FlowVPX products. So in this example, you can see on the left-hand side what would be a diagram of a typical traditional uv-vis spectroscopy instrument. To get concentration, it's based off of the Beer-Lambert law. Absorbance equals extinction coefficient times path length times concentration. In that type of instrument, you typically have a fixed path length at 1 centimeter, or on the process instruments, maybe it's 1 millimeter or 2 millimeter. And you get the absorbance value that has a range that's quite limited. So in that sense, you would have to do sample manipulation, like dilution, in order to get the concentration within the range of the instrument. In the variable path length technology, or slope spectroscopy, what we've done is we've piped the light through a fiber optic so that now the light source is actually in the sample. And the path length is defined from the bottom of the fibrette, or the fiber optic, to the detector. That fiber optic is connected to a linear stage that allows it to move up and down through your sample, changing the path length anywhere from very, very small values of 1 micron all the way up to 15 millimeters. So it gives you a huge range of samples that you can read without changing the concentration via dilution. The difference between the picture above and this one is with the FlowVPX system, you have piping connected to the system, and the fibrette is a stainless internal fiber optic that moves up and down, and you can change the path length while you're running your process. So in about 5 seconds, you can get a full acquisition of concentration. What I like to say, in a minute, you can get 12 QC grade concentration measurements. So throughout your process, you can continually get concentration measurements, monitoring what's going on. And now we look at the slope equation of slope equals extinction coefficient times concentration. So the system will give you the slope. It will give you the R squared to ensure that you have linear data, and it automatically divides by the extinction coefficient to output the concentration. So now I'll just go through some details on the FlowVPX system and some features that we have, and then we'll jump into the data. So the FlowVPX system is designed to be GMP grade. All the materials of process contact are certified, things like 316 stainless or EPDM. We have the system is IP65 rated and CE marked, and can operate in a C1D2 area. So if you're running oligos or peptides, you can use the system in that area. It has a vast concentration range. We have standards that go up to 46 slope, which equates to 460 absorbance for a standard spectrophotometer. It's scalable, and I'll show in the next slide why, but you can have various different flow cells that attach to the existing instrumentation. It has mounting screws that allow you to connect it to skids or other instrumentation, or even in the lab. And it has OPC UA connectivity so that you can provide a control signal to your process automation. If you don't have that, it also has analog outputs or digital outputs that you could use for your process control. And then one of my favorite pictures is in the middle right-hand side of your screen, where you can see the fiber optic suspended in the middle of the flow cell. It does not really obstruct the flow path, so these flow cells can run at high speeds, high flow rates. Here we have the various flow cell sizes that fit onto the FlowVPX head, and you can take the same instrument and use it at the lab scale at 3 millimeters, all the way up to a production scale at 1-inch pipe size. You can see the pressures and flow rate limitations for each of these flow cells. They're all GMP compliant. They have certs that come with them that are assigned to the lot number of the flow cell. So all that information is available on request when you get a system. Coming soon, mid-2022, is our single-use flow cell. They are the same configuration as our stainless flow cells, but made with PPSU, and will be e-beam sterilized so that you can pipe it into the process in a single-use process as well. Those will be available in the 1/2 inch and 1 inch pipe sizes. So this is the good part. Here we're going to go over the data of where we've used the FlowVPX system in various process steps. And I kind of like to do it in process order, so I'll start with chromatography and end with the filling. And let's just jump right in. One of our customers, KBI, put in a lot of work with the FlowVPE system on dynamic binding capacity. Here you can see a comparison of various antibodies, monoclonal and bispecific, and their dynamic binding capacity on a couple different resins. So the FlowVPX can be used directly to measure dynamic binding capacity while you're running a process. You simply read the concentration of the harvested cell culture fluid, use that value to subtract from the column effluent, and that information will be your essentially your binding capacity. You can see the breakthrough curve from that chromatography run, and then use that information to create these DBC curves. KBI gave a webinar last year on this subject. This is just a sampling of that information. And you can see that for one specific type of antibody, the binding capacity was very low compared to another using the same resin. So being able to do these real-time studies on real product allows you to minimize your development time and really get a quicker understanding of what's going on with your resins. Taking it one step further, they were able to look at the DBC for various different resins, affinity media, various different flow rates, different lots of materials, and then you can even do lifetime studies on your resin. So here you can see a couple graphs that are example from their work, where they look at different resin lots, they look at different flow rates, and they look at the different media. So using the same techniques that I showed about KBI, you can actually look at the loading, mass loading on your protein A column. If you see the top left-hand side, we flowed some harvested cell culture material through the FlowVPE unit to get a baseline signal. It was around 18 mg per mil. Then you flow it through your column as you would normally, wait a couple column volumes till the signal flattens out, and you can take the difference between those signals to get the titer in real time. Then, taking that titer value and multiplying it by the time and the flow rate, you can turn that chromatogram of concentration into a mass plot, and you can understand exactly how much mass is being loaded onto a single column. This is particularly useful if you're evaluating continuous processing or looking at multi-column processes. You can use these kind of techniques to really understand what's going on and change it for the different process parameters or product types. So moving on down the process, UFDF is really our most popular application for this instrument. Here's where you would use it on the concentration step. You would want to pipe the FlowVPX or FlowVPE into the retentate line as opposed to the permeate line. And you want to look at the retentate as the concentration is increasing. Using this technique, you can know exactly what concentration is flowing through your system at any given time. You can set start and stop points for the dye filtration if you like, and then you can set a final concentration point. This was one example. I'm going to show another one afterwards, where we did a study comparing SoloVPE offline measurement to A280 to FlowVPX, up to 260 approximately mg per mil. So you can even use this for your very high concentration MAB formulations. In the next example, we've broken it up into a few slides to show the set points for a UF1, a dye filtration, and a UF2. Here we did it on a pilot scale. So this was kind of around the 50-liter scale. where we ran the FlowVPE and FlowVPX directly against each other and looked at the concentration at each stage of the process. So you can see how it tracks here very, very closely. The UF1 up to approximately a 50 mg per mil set point. And then on the next step, we did dye filtration. Here, there was a little bit of issue with the dye filtration. One of the scales was off and it kind of raised the concentration a little bit. You can see it almost fell out of the set point. This is actually a nice example of how you could use the system to ensure that your process is operating properly, keeping the concentration constant throughout the dye filtration. And then the final stage of this process was actually quite interesting because this UFDF was done mostly manually. The target was 225 mg per mil, but if you notice at about 175 mg per mil, the system stopped automatically. This was because of a miscalculation of the holdup volume on the system. So at 175, the system thought it was time to stop, so it did, but in fact it needed to concentrate more. So manually, we set it up to concentrate up to 225, and we used the FlowVPE and X to make sure that we hit that concentration accurately before completing the process. So this UFDF was a particularly nice example of how you can use these information to ensure your process is working properly. And finally, just the comparison of each system, the FlowVPX, FlowVPE, and SoloVPE for each stage of that process. You can see that the values are extremely close, even at the very high concentrations of 228, 229 mg per mil. This is really important as you're doing tech transfers from site to site. Having this type of instrumentation that is relatively operator independent allows you to move the system from site to site or implement into a different manufacturing site at a contract manufacturer and get the same values in the same process. So process consistency globally. Finally, if you're working in UFDF in the GMP scale, often it's a big concern of the recovery step. This is where you're collecting your protein off of the system, and you often have to do a buffer flush to recover the protein. It's a scary part because you're diluting the protein just a bit. So here you can monitor that dilution and ensure that you don't go below the target concentration. So our GMP customers doing UFDF really appreciate this application. Finally, the drug product suite, where you take your bulk drug substance and dilute it to your formulation concentration. Often you're going to get a pool that's a very high concentration and you need to dilute it down to a lower concentration. There's really no room for failure in this process. Concentration is extremely critical and you need to hit your targets accurately. So having the insurance of a FlowVPX unit recirculating in your formulation tank will ensure that you're going to hit your target every single time, and it's been demonstrated by our customers in the past. Here you can just see an example of a plot from a drug substance to drug product graph going from 90 to about 5 mg per mil. Additionally, it can be used in drug product development, and on the right-hand side there are 3 graphs there, each corresponding to a different size sterile filter. And you can see the gray, yellow, and blue lines have very different product holdup on the filter versus volume. So in a typical filling suite, you might flush a certain amount of volume through the filter to ensure you're at a stable concentration point. It's not necessarily scalable. At the very small scale, it doesn't hold up much, but at the large scale, it kind of holds up a lot. So it's, FlowVPX is a useful tool for these kind of studies in drug product development. So in summary, the FlowVPX system can provide increased process understanding. It can reduce your cycling time or help reduce your cycling time and increase efficiency both of your real GMP process or in development. It can reduce your development time by allowing things like DBC measurements. It gives you a stronger process control with less risk, so you can ensure you're going to hit your targets at those later stages of the process where it's really important to hit the concentration targets. So thank you so much, and I'll be happy to take your questions now.
Okay, thanks, Ramsey. So the first question is, can you speak about validation in GMP setting for commercial production, or is that customer specific?
Yeah, so there are definitely aspects of the validation that are customer specific, but in general, you have a few things that you have to do. Usually what happens is someone will bring the system into the lab and they'll do some work in the lab on a specific process step. They're going to understand the process using the FlowVPX. Then there'll be a few steps regarding analytical method validation that you need to follow to potentially compare the analytical method of the VPX to some standard or an offline measurement that is accepted at that customer site. Then likely there'll be some software validation and software setup, or if you're connecting to a process equipment, some validation of the connectivity to that skid. And then just some process validation as far as cleaning parts or disposing of flow cells and how those things are handled, and some training that goes about that. So some of those things will be specific to the operation that you're running, but in general they're pretty standard, and we can kind of help along when you implement the system for recommendations on steps to follow.
And with UF and DF going to very high concentrations, have there been any issues with reading high viscosity solutions with the FlowVPX?
So no, that's actually one of the great things about this system. You're shining light through the sample. It doesn't really matter what the viscosity of the sample is. Now, you do need to be aware of how the material is being processed. So if you have a pump that contributes to agitating the material, or might cause bubbles in the material, what we would typically instruct you to do is to get to whatever set point you need to do on your UF-DF system, stop, allow it to recirculate and settle out so that the solution is homogeneous, and then take a measurement at that point. And that would only be for really specific samples at very high concentrations. With this system, we've run it up to 350 mg per mil for an antibody, so we've had no issues with viscosity at all, and we've been able to read accurately at those high concentrations.
And I'm curious to know whether variable path length is something that you set in the beginning, or is it changed in real time based on the UV-ABS data feedback in real time?
Yeah, so there's a couple ways you can use the software. The system gives you the ability to either set a method using what we call a fixed slope method, and that's where you would set a few different path lengths, and the system would read those over and over again, getting you concentration values at each different path length versus absorbance. Or you can use our quick slope or quick kinetics algorithm, and that's where it will automatically find the linear range of your sample and read the concentration based on that. So that's the most common way to use it, and that's the default method. You would just simply set it up to do quick slope. You input your extinction coefficient, and then it's just going to give you the concentration over time and automatically range to the appropriate path lengths.
Can the FlowVPX measurements be integrated with other process measurements? For example, temperature, pressure in UF-DF equipment, or would additional computer systems be required?
Yeah, the FlowVPX can be integrated to other process measurements. It depends on the system that you're using. In fact, so there's simple analog outputs that can send the concentration signal to other instrumentation, like the Repen KR2i or KTF systems. We can do that on our own internal systems, or if you have other manufacturers' processing equipment that can accept analog signal, then we can send that to that processing equipment and then have the concentration be alongside your other sensors. It also has the capability to do OPC UA communication. I know that Delta V can accept that, Siemens SciPat. So if you're using these other process automation softwares, if you have the OPC UA plugin for those softwares, then you can set up the FlowVPX to send that signal directly to that system and then use it for your process automation.
Okay, well, it looks like we have time for just one more question. If we didn't get to your question, we will be passing those on to Ramsey, and he can follow up with you directly. So, and also, if you still have any questions, just continue to type those in, and we'll pass them along. But the last question for the webcast is, do you offer demos of the FlowVPX?
Absolutely. So that's one thing that my group does quite a lot. We do offer demos. We ask that this is a serious inquiry and it's something where maybe implementation is imminent or you're really thinking about getting one for your lab. Typically you reach out to me or someone from our sales team and we'll set up a time to come in or given COVID, do a remote demo where we would send the equipment and one of the application scientists would help you set it up, run a process step, and then you send back the equipment. And then we can go over the data and see how the system works for your real process. So that's definitely something we do, and I'd encourage, as it really, I think, helps you see how this thing can help in your process from a firsthand perspective.
Thanks, Ramsey, and thanks to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.